In this tutorial, I'll be showing you guys several things, including how to draw out your own dungeon shape just like this using just PCG mode. Not only are you able to draw out the dungeon that you'd like, you can of course modify it afterwards, and you'll also get things like this: rounded corners, automatic pillars, and I'll show you guys how to select the inner corners and the outer corners as well, no matter which ones, so you can filter out different walls for one versus the other. Not only all of this, but inside the same graph, you can go and select the paint mode, and then here you could just go ahead and paint in some trees wherever you'd like. Or if you don't want trees, you can make your walls something else. You can make variations here. So here I can make my walls mossy, for example. I can also go ahead and scatter some bricks around just by clicking where I need them, or maybe just spawn some bookshelves around wherever I would like, as simply as that. And of course, it's a dungeon. There's bound to be columns all over the place, and you can just click and place them wherever you'd like accordingly. And of course, all of this adjusts with the size of the brush. So if I made a very large brush and clicked, I'll get a large area of trees. Easy as that. All within one PCG graph to allow you to customize your setup however you'd like. Let me show you how it's all set up. To get started, as always, make sure you go to Edit, Plugins, and enable PCG by searching PCG and turning on your procedural content generation framework, and restart your engine as needed. Now, this entire thing is going to be inside of one PCG graph, so we'll go ahead and create a PCG graph. We'll make an empty graph, and I'll call this PCG_dungeon generator. And I'll go ahead and open it up. The first thing we'll do is configure the tool information. That is in the detail panel right when you open it with nothing selected. This is your tool data. This is what actually is selected in the PCG mode. So we'll configure that first to make sure that it's all working and go from there. The display name is what do you want it to be seen as. I'll call this dungeon generator. For the tool data, I'll just say spawns drawn out dungeon. Now for the compatible tool tags, we're going to actually need two of them. We're going to be using the draw spline surface, and we're also going to be using the paint. So we want to type in spline surface tool and the paint tool. So spline surface tool, paint tool. You can go ahead and attach to an actor, and we can give it a new label for the actual spawn thing. We'll just call this generated dungeon, and I'll go ahead and turn it on as a preset. And then if we go back to spline, draw spline surface, you should see there's your dungeon generator, and under paint, and we select paint here, there's again our dungeon generator. And so you know you've set this up properly. Once that is set up, first thing to do is to actually set up the walls. We're going to do the walls first, then I'm going to show you guys how to do the interior and exterior corners, so you can have randomization there, and then we go on to the paint section. So for the actual walls, I'll go ahead and right click and do get spline data, since we'll be drawing this out, and then we just do a spline sampler. Now spline sampler, we're going to change from on spline to on interior. We're going to make sure unbounded is checked. This is because we don't have a volume that houses all the points, so we want to just be within the entire spline here. And then for your spacing here, this depends on the size of your pieces. My pieces are 200 by 200 in size. So in terms of the floor tile, they're 200 squares. So in my case, I'm going to be setting both of these values to 200, but if you're using a different setup, then adjust it to those values instead. Now we're going to need this in a few locations, so I'm going to drag this out and search for name. I'm going to add a name to reroute declaration node, and then I'm going to just F2 to rename it and call this spline interior points. So that way, if we need to use this somewhere else, we'll just have this instead of having to grab a giant path from here. Now the floor that I'm using is a brick one, but I don't really like the look of just all the bricks being flat across. On a large scale, I feel it doesn't look great. So I found that it actually looks really nice if I randomly rotated them, all within 90-degree increments. So that's what we'll do. If you, of course, want to just align your floor up, you can skip this part, but I think it gives a nice aesthetic. So from this spline interior points, I'll drag out and search for attribute noise. This will give us a random number. And what we want to do is change the input source here to point density. It doesn't necessarily need to be density, but density has only one value here, compared to something like position, which has a vector. We only need one scalar value, and density has it, which is why I'm using it. The output target, I'm going to create a new attribute for that, so I'll call it rotation. I'm going to set it between 0 and 3. So we get a random float between 0 and 3. So I want an integer, so I'm going to round that value. Now, so we can actually start seeing this in the world and actually debug this, I'm going to go back to my spline, draw surface spline, dungeon generator, and I'm going to draw out a little bit of a dungeon here. Now, we're not going to actually see anything, but you'll see that we actually start getting the information once we start debugging them. Now, I've drawn this out, and it becomes a big curved thing. So if you want it to be fully linear, you can just click on any one of the points, right click, select spline points, all spline points, and then right click again, spline point type, linear. And this gets you a nice linear setup here. And then if you get out of the PCG mode, you can go ahead and configure this to your heart's content, and Control Shift will allow you to select multiple at once and move them. So if you want to, we can hold Alt to add more and kind of fiddle this into what we actually want it to look like. Now, we're not seeing anything in here because we haven't spawned anything, but back here, if we go in the bottom left corner under debug object, we can go ahead and select our component here, and then on round, we can press A, and you'll see there's our information of the points, and all the way to the right, you'll see there's the rotation. It is now a random integer between 0 and 3. So all we can do is take that random number and multiply it, well, by 90 degrees. So this gets us the resultant angle that we want to offset with. So from the original spline interior points, I'll drag out and search for add attribute. We want the math operation here, and I'm going to go ahead and plug this multiply into this add. So on input source 1, what we want to do is hit the plus button, go to point rotation, but we want to specifically do rotation dot yaw. It is not rotation XYZ, it is rotation dot roll, pitch, and yaw. Yaw is the Z axis, so that's the one that spins around. So that's what we'll be using. So we're setting that with the last value here. And the last value that was used here, since we keep using last here, it's last here, is the last one we set, which is rotation. You can specify rotation in here specifically as well. That also works. But we basically take the original rotation, add the rotation, and then we save it back onto rotation.yaw. But now we can go ahead and grab ourselves a simple transform points node. And to make it a little more interesting, I'll make a slight variation on the randomness here. I'll have it go between 0 and 3 up in Z, and I'll have it just randomly rotate between -1 in XYZ to 1 in X, Y, and Z. Just a very slight rotation. And then we can go ahead and use a static mesh spawner, and here we can go ahead and specify the meshes that we want to use. In my case, I have these regular floors, so that's what I've plugged in. Just 2 floor variations. Now if we take a look, you can see, well, there's our floor. And now that we actually see it, we can now say, okay, you know what? Maybe we want to change some things. For example, this angle is just very weird. So let's go ahead and maybe adjust things, straighten things up depending on how we want the actual dungeon to look. Maybe we don't want this little gap here, right? We can just go ahead and clean it up and make it look like we want. Let's say something like this seems good. And if we can come down here, we can see there's our floor and it is randomly rotated. Some of the bricks are going one way, the other is going the other way, and it feels a lot more interesting. Now, one thing to note is it is kind of embedded into the floor. So all I'll do is just have the whole thing selected as a main actor here. And then I just go ahead and move the entire thing, let's say 20 blocks up. This only depends on based on your actual mesh. If your pivot was all the way at the bottom, it'll probably look fine. Also go ahead and select the floor, and I'll just replace it with a floor 01 material, which is a default engine one. If you don't see it, you can click the cogwheel here and make sure plugin and engine content is turned on. And then you'll see this M floor 01, and then go ahead and just assign it here. Now, what immediately happens is the entire thing gets blown out. So I could give it a post process to kind of fix this, or I can go under perspective here on the top and turn off game settings. I'll then go back in and just change the EV100 to 0. So now we can see it is now no longer completely blown out here, and we'll no longer use the auto exposure settings. So from here, we can go ahead and change the values. For example, change the light direction, intensity, adjust the angle, or whatever you'd like. This is just for preview, but if you were to do this in your own project, post process is the way to go. So fantastic. We now have the floor. Let's go ahead and do the walls. Now, quick note, it seems there's a slight bug with comments. If I make a comment here and call this something main floor, for example, it seems the comments either don't move or don't get updated. If you ever do something else and then come back to it, it seems like they go away a lot of times. It's an unfortunate bug, but I have noticed it while doing this, where I made a comment, moved something, did something else, and then I look back and it's not there. So just a heads up, a little buggy. For the walls, we're going to go right over here and then grab our spline interior points. And we need to offset them in 4 directions. So we'll use a transform points node. I'll go ahead and open it up. And then by holding 3 and clicking left, you'll get a constant vector here. This is similar to how it is in materials, so it's very convenient. And now what I want to do is set this up where the X value is 100. It's 100 because it's half the size of my floor piece. My floor piece is 200, so we're using half at 100. That is going to go into offset min and offset max. I'm going to close this up. And I'm going to go ahead and just copy paste this 3 more times below, where we're going to change the values on these create constants. On the second create constant we have here, we're going to make it -100 in X. On the third one, we're going to change X for Y, so it'll be +100 in Y. And the last one will be -100 in Y. And we'll make sure these spline interior points go into the in of all of these. Now, these offsets are good, but they do require rotation as well, because when you create the walls, we want the main block to stay where it is. And then based off of that block, right, it needs to push forward in whichever direction it needs to go, which means each one of those walls needs to be forward in that axis. So we need to rotate each one accordingly. So the first transform points here is going to be negative 90 on the Z. The second one is positive 90 on the Z. The third one can be left at 0, and the fourth one is the exact opposite of that at 180. So the y-axis is 0 and 180, and the x-axis is negative 90 and 90. From here, we're actually going to be using this information down the line in a different area when we're getting the corners. So from here, I'll search for name one more time, and I'll add a new add name reroute declaration node. I'll press F2 to rename it. I'll call this side A, and I'll do the same thing for the other ones. I'll just add a new one and F2 to rename side B, C, and D. So there we go. Just like that, we have now A, B, C, D. So we can go ahead and reuse this down the line in other locations. But the first thing is we have 4 sets of points that have all been duplicated on interior. So we want to cut each other out. The reason we did half movements is because based off of the center of the actual square, right, you want to do half movement to get to the edge of that square. And what we're going to do is just check, hey, wherever all of these are intersecting, that means there's another square there. We don't want those. So we're removing those, and only the ones that are not left overlapping, which is the exterior ones, are going to remain. So what we need to do is actually use a few difference nodes. So we'll grab difference, and we'll need it 4 times here, one for every single direction. And the source will be the side that it's on. So side A will go through, B will go through, just like that, just straight through. But the difference will be the opposite between these two. So A will have B removed from it, and B will have A removed from it. C will have D removed from it, and D will have C removed from it. So a little bit of a cross here. After this, we can go ahead and just drag out and search for a merge point. So we put them all back together, and we can have all 4 of these difference nodes recombined just like so. If I go ahead and select and press D in the world, this is the result that you should see. You should see a nice clean border on the outside, just like so. So this is working really well, which means we can just use a static mesh spawner and plug in our walls. And then we'll get something like this, where we have random walls. And in my case, I've also put in random windows with bars in. Now, if you want more or less walls compared to windows and you're using this method, all you need to do is go in the static mesh spawner and adjust the weight. The window bars have a weight of 1 for me, but the actual walls have a weight of 2, which means there are approximately 2 times as many walls as there are windows. Now, if you wanted to specify where these windows are, there are 2 ways of doing that. One is you could use grammar for this exterior wall section, or 2, you can use one of the methods that I'll be showing you in a little bit using the paint method to specify where exactly you're putting a window and not. For now, though, we're going to call this good and move on to grabbing the corners. For the corners, we're actually going to need to offset all the points one more time by this value, by this first angle. So we're going to copy this, we're going to paste it here 4 times, and then we're going to take side A, plug that into the in, then side B, side C, and side D. We'll plug them all the way through. And we'll need this in the future for both of the corners. So I'll go ahead and, like before, search for name, add a name declaration node, rename it to side A offset, and then we'll do the same thing for the other ones. Name, side B offset, C offset, and D offset. Now, if you're wondering why we're offsetting all 4 directions by this value, I'll be honest, this is from 5.3 when this was figured out, and I do not remember. All I know is you need this or it won't work, but for the life of me, I cannot remember why it is that we need to offset all of them in the same directions, because it shouldn't matter, but it does. That's one of those, you just gotta do it, and then it'll work kind of scenarios. So let's go ahead and grab one of the corners. We're going to be using these values, but it's going to be using the different stuff like before. So just take all 4 of these, duplicate them down here. And just like up here, instead of side A, B, C, D going to the source, it will be the side A offset, B offset, C offset, D offset. So it'll be just like this. And now for the differences, for A, we want B and C as the offsets. So I'll go ahead and duplicate those and plug those into A. For B, we want A and D. So I'll plug A and D into the differences of the second one. I'll go ahead and space these out a little bit more so you guys can see it better. For C, it is also A and D. So I'll go ahead and put A and D in this one as well. And the last one here, you might have guessed it, is also B and C, just like the first one. And we're going to need to still split this up even further because they're going to grab the sides basically and too much information. So we're going to use 2 more difference nodes. The top 2 are going to the source of the top one, and then the differences of the bottom one. As you might have guessed, the bottom 2 are going to go into the source of the bottom one, and the differences of the top one. So then what we could do is just do a simple 2-point, and you'll see the spatial 2-point. And you plug both of these in here and press D on here to debug it. And if I zoom out, you will see there's our corners. So these are the ones that are kind of sticking outwards. The ones that stick inwards are not selected. So we have one of the 2 corners selected using this method. And for convenience, I will go ahead and use a merge points here as well, just like we did here, just so we have all of these points in one piece of data. And this is for convenience. You could technically also remove it here if you didn't want to. This is more a convenience thing if you need to use this down the line. But now that we have these points, these are the corners, well, we need to remove them from the walls here. The original walls need to not have these corners filled in because we're replacing them. So from these original walls, I'll just drag out really wide here. And then after this merge points, I'll use a difference node, and that's going to go right before the static mesh spawner. And we want to plug this merge points into the differences, but we want to slightly modify it first. So what I'm going to do is drag out of the merge points and search for bounds modifier. And all I'm going to do is take all of the scales of every single axis and make them 0.5. So we're only going to get a half of the size of the points. Otherwise, if you leave them at full 1.0, it has a tendency of grabbing things a little bit too far. So 0.5 gets rid of that problem. And that is going to go into the differences. And the last thing here is on this differences, instead of minimum, I'm going to change this to binary. And what you'll see immediately is all of those corners are now gone. Now this is all cool, but you know what? I would like some of them to still be the normal corner. I don't want every single one of them to be replaced with my custom corner. So from this merge points, I will use a select points node, and that is going to go into the bounds. And on this select points node, we can specify what percentage of those points do we actually want to actually swap out. So I'll say 0.5. So now half of the corners approximately are now gone. And now we can replace them with our custom corners. So we'll actually need the select points for the other section as well. So I'll bring it down here. And then from the select points, drag out static mesh spawner, and then plug in your mesh entry here. In my case, I'm using a curved wall. And then you'll see that we do have the pieces here, but they're kind of rotated wrong. Why is that happening? Well, that's because on the offset one, we duplicated the transform points and they come with rotations. So I actually want to reset all of the rotations in all 4 of these transform points. The offset is correct. We don't want any of these rotations. So we'll go ahead and zero them all out. And when you do that, you'll see there's our new wall piece. Now, if you're wondering how this is angled, if we take a wall here, you can see this wall happens to go in -x and -y from the middle point. So that's how this one is designed. If yours is going positive, you might just need to add a transform points right before the static mesh spawner to rotate all of them 180 degrees, whatever yours is set up as, depending on kind of which quarter of a circle you're using. And I should mention, all of these pieces that I'm using are free and available online, and I'll make sure to leave a link to them in the description below. So now we have a few nice rounded pieces. That's great, but what about these corners here? We now need to fill these ones in because, well, they look kind of bad. So let's go ahead and now grab these inner corners. Or I guess you could think of it as the corner that kind of faces inwards versus the corner that faces outwards. For the inner corners, I'm actually going to take all of these and duplicate them down below, and then we're going to modify these differences. I'm going to leave A and B here, then B and A. Then we want to keep C and D, and then D and C. So A, B, B, A, C, D, D, C. Then they're removed the exact same way, combined the same way. The only difference here, I don't want to do the select points. What I want to do is remove these corners from here because they're going to be including all corners on this inner one. So from this merge points, I'll use a difference node, and I want to remove the points before the select points because the select points is only for what it's spawning. It's still a corner even at this merge points node. So these merge points node is what's going to go into the differences. And if I go ahead and press D to debug this difference node, you'll see that's the rest of our points. Those are the ones all that are kind of facing inwards. So now what we can do is add ourselves a transform points node as always, and then plug that into the static mesh spawner. And all we need to do is swap out the mesh that we're spawning. In this case, I'm spawning a column. And if we take a look now, you can see there's our column. It is just really wedged in there and it is a little bit small. So on this transform points, to make it a little bit nicer, I'm going to offset it by -20 on X and Y. This will kind of push it out towards the room so it will not be embedded into the wall. And I'll also scale it up just a little bit by 1.15. So it's a little bit bigger now. I'll keep it on uniform scaling. This is fine. And thing as we take a look now, you can see there's our nice pillar. You can see it is now offset off of this wall and off of this wall. So it looks a lot nicer like this. And this happens everywhere. So you can see our corners are nice and hidden. We don't see that mess of a connection there. And then occasionally we have this nice looking corner one that has rounded in. By the way, you don't have to have this rounded in. As long as you have your pivot point here, you can make this any shape you'd like. You can make this diagonal, you can make this straight, you make it a hexagon. That part doesn't doesn't really matter. All that matters is you're using the same modular shape in terms of the size of it, and just keep in mind that the pivot is going to be in the corner there. So awesome, we now have the inner corners and outer corners. We can draw everything out. So that is all looking nice. So now we want to go ahead and customize this. We'll start by being able to just click and paint in some trees, which means we'll be using still the PCG mode, but we'll be using the paint section this time, because now we can customize based off where we click. I'm going to go up to our main floor here, and then I'm going to right click and search for tool. And we want to get tool data. This is the thing that gets us the information from the paint tool. So the tool tag here will be paint tool, and the data instance is what do we want this layer to be called? I'll call this layer trees. So what we're going to be doing is spawning a tree, and we're swapping out the floor piece that has kind of the little green spot for the tree, which means we need to kind of separate those out from the current static meshes. So we'll drag this out from the transform points. We'll use a difference node. This difference node, instead of minimum, will be set to binary, and it's going to take this get tool data into the differences. So go ahead and remove where we click here, and then whatever is left, that can go ahead and still spawn the original static meshes that we had. But to get the remaining, so the opposite, so get where this has been clicked, we could just take a difference on the difference. So we'll just right click, grab ourselves a new difference node. This one's set to the default minimum, and it's going to take the original transform points and is going to remove the difference binary into the differences. So we're basically taking the original points, removing some, and basically doing the inverse. You probably also do an intersection here, but the main thing is we want to use the original points as the main points, so that way it lines up to the grid automatically. Then just like the other one, we go ahead and put in static mesh spawner here. The only difference is on the static mesh spawner, I'm specifying the new floor piece that I want, and then to spawn the trees on top of them, we just need to use a transform points node to randomize the trees now. So we'll have the trees rotated 360 degrees on rotation.z, so it has a random rotation, and we'll have a random scale between 0.8 and let's say 1.2. Then we can use another static mesh spawner and then populate this with the trees that we have. And now we can already try this out. If I go ahead and select the dungeon here, shift 9 to go to PCG mode, go into the paint tool, and make sure dungeon generator is selected. You should see here is your data instance of trees that we created here. And now I can go ahead and click in the middle of these, and you'll see it places a tree down. Wherever you click, it now places a tree. And hold shift and erase them. Just dragging over, holding shift, I can erase. And if I make the size of the brush bigger and click, it will place more of them. You can see that is our little tree that we can place wherever we'd like. And just like that, we can just click our little few more times and get some trees placed in. Nice and easy. And by the way, during this entire process, I have not hit accept. You don't have to, but if you do, just remember that you need to reselect the dungeon every time if you want to keep adding onto the same graph. The next thing I want to kind of paint in is some moss on the walls. I have different kind of walls, so I want to be able to swap them out for a moss covered one or a leaf covered one. You can of course use this to swap out entire walls for windows or for doors or anything like that. I'm just showing you the tools to do it, and you can use that for your own setup to swap out however you'd like. Since we'll be doing the walls again, we need to do this after this binary difference node. So I'll go ahead and right click, get tool data one more time. Tool tag again is paint tool, and the instance or the layer is going to be called moss walls. Then just like the other one, we use a difference node. We set it to binary, and that is going to remove these points here, and that is going to go back into the static mesh spawner as before. It's the same thing as the other one. And just like the other one, we'll use the difference again to basically get the original points minus what was left. And then we go ahead and duplicate this here, and then plug in your new variation. Now the main thing here for the wall specifically, if you're just making a variation of like an overgrown version and a non-overgrown version, you want to make sure that the seed here for both of these static mesh spawners on this one and this one is the same. If it's not the same, you might accidentally replace a wall with a window instead of just making it overgrown or not overgrown. But once you have that, again, select your thing, go to paint tool, dungeon generator, and here we need to change the data instance to moss walls. And now if we come here, we can go ahead and just click next to a wall, and you'll see there's our moss walls. And then just go click again and swap them out. Easy as that. Just click and it will replace this with a nice mossy version. And this can be done anywhere, including, of course, these, because it's all from the same static mesh spawner. So I can go ahead and make these have nice moss here. Easy peasy. And of course, like the other one, just hold shift and you can erase those original points or add them back in. The one note here is the corners, the ones that are remained to be outer corners. If you click here, it will place them on both because the point is kind of in the same location for both of them. It's just the wall is facing one direction and another direction. So keep that in mind. There we go. Now we have nice mossy areas of stone wherever we want. Fantastic. But this does not cover the corners. So if you want to do the corners, I'll go ahead and take this overgrown walls. I'll just copy the entire thing. I'll go in here to the outer corners, for example, paste it in. And all we need to do is take the static mesh spawner and replace it with this top one, because that is the original ones. And then take this conversion node and we'll just hold control and plug it into the select points that it was originally. And then on this static mesh spawner, just swap it out for the same kind of wall as you had here. Again, make sure the seed is the same between the two, but the overgrown version or the mossy or whatever you have as variation. And then we can go to where this is, click, and there we go. We can make even this curved one have this variation. The inner corners are pillars, so we don't need to do that. But if you have a variation of the pillars, you can do that there as well. Now this is nice and all, but let's put in now some bookshelves. We want to be able to just click and place a bookshelf. Now in my case, I want the bookshelves to be against a wall. So we'll use the walls again for these placements. If you wanted to, you could make it so you can click anywhere in the world and place a bookshelf automatically there. I want to do it specifically against walls, so that's going to be the setup. But don't worry, I'll be showing you how to set up pillars and bricks. Then you can use the same method for the bookshelves. I'm going to go here to the overgrown walls section. I'm actually going to just move this conversion node a little bit to the left. I'm going to go a little bit up and then copy this get tool data with a conversion node here. In this case, we're actually going to use an intersection node. So wherever the original points intersect with these, that is what we keep. So you can see we can also use intersection nodes. The only difference is it's not moss walls that we're doing here. We're doing bookshelves. So from here, I'll just use a transform points node. And then as always, a static mesh spawner. I have two bookshelves here that I've plugged in to the mesh entries. And so if we come here, select the dungeon, go to paint, change this to bookshelves. We can now click next to walls and place them in. But you'll see that if we place them in the corner, it will do both of them. But the other thing you might notice is if I click somewhere, well, they're kind of facing the opposite way and they're kind of embedded into the wall, which is why we have the transform points node. So here on the transform points node, for my bookshelves, I'm going to move them -70 in Y, and they were flipped the wrong way, so I'll move them 180 degrees in the other direction. And you'll see there's our bookshelves. So now I can go in and place bookshelves wherever I'd like just by clicking next to those walls, and we can have nice bookshelves here. Again, corners will have both because that's kind of where the point is that you're overlapping. But if you move it a little bit to the left here, you can on these kind of points get both of these just like that as a separate shelf. So just be careful where you click, basically. It doesn't matter if there's a window there or not. You can still block it off if you'd like to. Just go ahead and click or click and drag. It doesn't matter. And nice and quickly, you can have a bunch of bookshelves placed around. Again, it doesn't do anything. If you click in here, it'll just create a point, but it won't actually place a bookshelf. It'll only place bookshelves along the walls. But let me show you how to spawn things wherever you'd like. So we'll do that for some bricks and some columns. I'll go ahead and start with the bricks. So I'll just copy this get tool data node and I'll just place it somewhere around here. I'll just change this data instance to say bricks, because in this case, we're spawning bricks. And all it's going to do is drag out, use a transform points node. And all I want to do is rotate these bricks 360 degrees. And I just want a little bit of variation here on scale between 0.8 and 1.2. And like before, setting my spawner, add mesh entry, and plug in your bricks. And as before, make sure your thing is selected. Go to paint, dungeon generator, select your bricks. And now I can go ahead and just click wherever I'd like some bricks. It doesn't matter where I put them. I can put them anywhere I'd like. They don't even need to technically go inside of the dungeon itself. I could even click them outside of it at this point, but there's no point in putting them there. So now we can go ahead and make some nice, interesting variations here. And if you wanted to, you could have a bunch of different things here that you scatter around. So if you wanted to, you could have bricks, papers, it'll just randomly select them. And then every time you click or paint, it'll go ahead and place them to make this place far more interesting. Just little by little. There we go. We have a few bricks lying around. I think that's quite nice. I can add more down the line. Let's go ahead and add the columns in first. And the columns are pretty much going to be the same thing. We're just going to duplicate them down here. Instead of bricks, the data instance will be columns. The only thing is I do not want to rotate them automatically. And I'll also go ahead and reset the scale. This is where you can put in your modifications if you so wish. But really, I'm going to just place the columns as I click. The only difference is I'm going to swap the bricks for the columns. In my case, I'm using the bridge support columns. And I can go back in here with the dungeon generator selected, swap it to columns. And now the main thing is before I start clicking, I mean, you can do it after as well, but I'm going to use this rotate yaw step size to 90. So on my piece, you can't really see it, but if I go over a flat surface entirely, there's this red line. If I rotate by just scrolling on my scroll wheel, you can see it rotates now in 90-degree increments. That's what this 90 is, which means I can now specify in what angle do I want this pillar to face every time I click. If I click this way, you can see it is facing left. If I scroll twice more and click, it'll face the other way. So I can make it now where it will face where I want to, and I can click where I want them to go. So we can have some nice variations here. And just like that, we can have a few pillars just scattered around. Now that we place the pillars, maybe I'll want to scatter in some bricks just around these columns in some areas. elements. Maybe not all of them, or maybe just a few to give it a little more interest. And we can tell a story that maybe something above fell down. But just like that, we now have a full dungeon that we have drawn out with interesting corners and variations on them, or we can paint in moss, bookshelves, trees, columns, and anything else we really want to, because the way we're going to add more stuff is the same one thing. We could swap things out using the difference method, or just add more to paint in wherever we'd like. So if you want to make a nice curated room and you don't want to hand place things, this is a great way of doing it. Of course, this is not procedurally generated layout. A lot of times you want to have it make sense logically and tell a story, and that's just easier done a bit more manually. Now, as always, the project files for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the links with everything else will be down in the description below as always. And if you're looking for more awesome PCG tutorials in 5.7, check out this one right over here. I think you're really gonna like.